I'm going to redo my video on completing the square real quick because I feel like the last one wasn't as concise as I would have preferred. So let me start off by writing just some quadratic equation. So the process of completing the square is going to give us the answer of what x values make this statement true, or what x values makes this quadratic here equal to 0, in other words. So completing the square can also be used to rearrange quadratic equations into other forms, and I think I'm going to do a video on that, or I did a video on that as well. So let's see, x squared. So first I start by dividing everything by 3 and putting it into this form, which is an equivalent form. And then from here, I want to move my 7/3 to the other side of the equation. And I'm left with x squared plus 5/3 x is equal to 7/3. That's equivalent to the previous statement as well. But here, I want to find out how I can contract this into x plus and minus some number squared that's going to be equal to some other number. That's the goal of completing the square. So I'll do a diagram here to show you what I mean. So as it is right now, here, I have two pieces of information. I have the x squared term, and then I know this has an x dimension that way, and this has an x dimension that way. So I'm asking what length here plus length here will give me the quantity here, 5/3. Well, I know it's going to have to be half of each of those in order for these two rectangles to add up to be 5/3. So it's going to be 5/6 is going to be that length that I want. If that length is x and that length is x, then I know I'm going to want 5/6x area for each of these. And you can check by saying 5/6x plus 5/6x is 5/3 x. So this is what I mean by completing the square. Quite literally, we're figuring out what piece we need to add to this so that we have a square that we can contract like that. So it's going to be 5/6 times 5/6 is 25 divided by 30. I'm sorry, 25 divided by 36. And that can't be reduced, so we can leave it as 25 divided by 36, and I will just add that to both sides of the equation. So if I add 25 divided by 36 to this side of the equation, I'll have to add it right here as well. Sorry if that's really hard to see. I'll just erase this square now that we've seen how it works. Okay, 7/3 plus 25 divided by 36. And then I can see this is going to contract into x plus 5/6 squared. That's what I was showing with those two equal sides of that square. So 7/3, let's see. If I want to put that into that form, I'm going to have to multiply 3 by 12. And so I'll have to multiply 7 by 12, which is going to be 84/3. I mean 84 divided by 36 plus 25 divided by 36. Hopefully I don't make this floor start to squeak. Okay, so then I can add 84 and 25. It's going to be 109 divided by 36. And then I'll see if I can reduce that anymore. I don't think that can reduce anymore, but correct me if I'm wrong on that. So this is going to be x plus 5/6 squared is equal to this rational number, 109. So then if I take the square root of both sides, I know that this number is actually going to be plus and minus the square root of 109 over 36, or x is equal to negative 5/6 plus and minus the square root of 109 divided by 36. So these are the two answers to this problem. If I were to plug in these x values into the original problem, I would get zeros there once I multiplied everything out. So now I'm going to do a generalized form of this, or I'm going to solve for the generalized form ax squared plus bx plus c is equal to 0. And I'll have a little diagram here of what I mean. So the first step is to divide everything by a to get the leading coefficient to be 1. And then second step is move the c divided by a over to the other side, or subtract it from both sides rather. And then I have x squared plus b divided by a, x is equal to negative c divided by a. And then if I want to draw my diagram of everything I have on this side, or everything that's being multiplied by x. So if I let this side be x and this side be x, I know I have an x squared piece. And I have b divided by a. That's going to be split up between these two pieces here. So I can put half of that here, b divided by 2a, and b divided by 2a. And I know each of these has an x dimension. So if I were to take that rectangle, put it over here, I would have b divided by 2a length and b divided by 2a length. So that it's, so that I multiply that by x to get the area of those rectangles. And since they both have an x dimension, we can combine them and add them together to be the b divided by a part here. So these three rectangles represent that area there. So the question is, what do I need to add here so that I can represent this as x plus b divided by 2a times x plus b divided by 2a? The answer to that is going to be b divided by 2a times b divided by 2a, or b divided by 2a squared. So that's what I'm going to add to both sides. And then, now I have each piece of this square right here, and this is also equivalent to the previous statement since I just added the same thing to both sides. So I can contract this into x plus b divided by 2a squared. That was the goal here. And this part is going to be b squared. So it's going to be b squared over 4a squared. But if I want to combine the fractions, I'll have to multiply this by 4a in the numerator and the denominator. So if I do that, it's going to look like that. So once I squared this, I would have b squared over 4a squared. And I can multiply the numerator and the denominator here by 4a, and I get minus 4a times c, and I can combine them into that fraction. And then I'm going to take the square root of both sides of this equation, and I'll have plus and minus the square root of b squared minus 4ac divided by 4a squared. Just have that a little shorter. And then the square root of this side will just be x plus b divided by 2a. And then I can subtract the b divided by 2a. That's going to be plus and minus. And if I take the square root of the numerator, it will just be b squared minus 4ac. I can't factor that into anything else, so it's just going to stay as it is. But if I take the square root of the denominator, I'm left with just 2a. Since 4a can be represented as 2a times 2a. And now I'm going to have negative b plus and minus the square root of b squared minus 4a AC divided by 2A. So I can combine those fractions. All right, and this is the quadratic formula. So if we generalize A, B, and C, we can still solve for x, and it takes on this form here. So one important thing to note is that if I have a negative number under this radical here, that would be taking the square root of a negative number, which we can't do if we're in the real numbers, but it will make this a complex number, which basically means it doesn't, if we have a quadratic such that it gives us b squared minus 4ac is negative, so I can say if b squared minus 4ac is less than 0, then there are no real roots. In other words, when we graph it, if this is the x-axis and that's the y-axis, it's going to take some shape like this above the x-axis. It's never going to touch the x-axis, so there aren't any roots to be able to graph.